Today, we're gonna see some of the basics in Arduino programming. Before going on to our topic, let's see an overview of Arduino. Arduino is an electronics company in Italy who manufactures microcontroller boards. Unlike other electronic boards such as PCBs that we see inside a radio or mobile phone, Arduino functions differently prior to a running code in it. The code is first made and is uploaded to the board. The code we use here is Arduino programming language, which is a simplified version of C++. Once uploaded, the board is independent of connection except the power. You need not always connect the Arduino with the computer in order to use it. It can run even with an external supply or external USB supply. The code is saved in its memory, its EEPROM. EEPROM is a type of read-only memory that is electrically erasable. You can erase its contents by electricity. But it isn't at all easy as it seems to be. You have to be a pro in electronics to do that. However, we aren't moving for that. We have our Arduino here. To use the board, you don't need to study the super complex board circuitry, and if you do want that, you are gonna spoil your brain for a board. Okay. Arduino company makes several kinds of boards varying with features and functions they perform. For example, if you are a beginner, I recommend you to use their Uno version. If you expect much more features, you may have a board that has even more features in it. So you may go for Arduino Mega version. The company manufactures several different kinds of boards with varying prices. Arduino offers open source platform for programming, which means that you don't need to worry if you modify their board and sell it by yourself. Several other companies use their board circuitry to make boards by themselves and is sold with other names. You can do this to any open source software or hardware, but if it's done on any other kind, you'll be in prison for violating the company's reserved rules. Let's take a look on the board. This is the microcontroller you see. It's the main part of this board. The code you upload is executed here. It's manufactured by a company called Atmel. Atmel is a well-known company who serves Arduino with their microcontrollers. Next, we have this. This is an oscillator. It fastens the back and forth transmission of data to the microcontroller. This is another microcontroller where the code we upload is stored. It also helps in the transmission and receival of data from or to an external component or computer. Next we move on to programming. For that, we need some different kinda compiler, Arduino IDE, by Arduino. I've given an URL where you can get this, or if you are a Windows 10 or 8 user, you are most likely to get it on Microsoft Store. Search for Arduino IDE there. After installing and opening, here we have the Arduino IDE window. Every code is saved in default as Sketch, which is just a fancy name, with extension .ino. Click on File and click on Examples. Here you get several examples made by several professionals. You can use them. Now, let's use this. This is just a simple code to blink an LED. Every instructions for the component assembly is given in the top. They have used the Arduino's built-in LED for this. I'll explain how to use an external LED for this. But now, let's try this out. An Arduino code has two main parts, the setup and the loop. Without these, the code won't be executed and will count as an error. Void is the data type preferred here as it doesn't return any values. If you want to know more about C++ data types, you may need to study the basics in C++. You can by ear both these things. The setup contains all the setup functions like the pin mode here. Pin mode declares the mode of the pin, that is, whether input type or output type. If you want to exchange data, that is you want to display information or data from a module connected to the board, you may add serial.begin. And in parenthesis, you type the data exchange rate, normally it's 9600 and terminate by semicolon, the same syntax in C++. If you don't put the semicolon, that's an error. Okay, let's jump on to loop. That loop is the part of the code here that executes or runs over and over again. Inside we have digital write, and in parenthesis LED built-in high. This denotes that write the voltage through pin or built-in LED digitally is high. Thus, the LED will glow up. We have the next thing is delay function. Delay function delays the execution to next statement for that specified time. Here it's 1000 means 1 second. And then, digital write low. Sets the LED low. Then delay. In a nutshell, the loop first turns the LED on and waits for a second and turns it off and waits a second before it jumps to the beginning of the loop. Thus the LED blinks with a second delay. That's it. If you want to include a library, type above all statements, simply at the top. The syntax is #include and the library name.h inside angular brackets. Let's upload that. Here it goes. It's uploading. And is uploaded. Let's see it. The LED is blinking. But this is a built-in LED. For you to connect an external LED, you have to connect the negative part to the ground, denoted as GND in the board in the digital pins array. And connect the positive end to any pin denoted in number except 0 and 1. They are used for other purposes. Let's do that. Out of the functions, declare the connected positive end of the pin as a constant integer of simply integer. Constant gives you promise that it won't be changed anyways. So, constant int, specify a name, here it's LED, equals 12. I've connected it to 12. Then replace every LED built-in we had with our new variable LED, then run it. Okay, let's wait and see the LED blinking. Yeah, it's working. That's it. You can find many such as fading an LED, it just uses the for loop to eventually reduce the voltage with delay and increase it. And using servo motors and much more. You can make about everything you want if you learn this, and many of them are available here. Sensors that read values and other things. Okay, that's for now. We'll make another video with other things. You can support us or help us improve by sending us feedbacks. We are always there to respond you. You can become our patron at patreon.com/matrix.llc. We are also in YouTube, Facebook, LinkedIn. You can chase us there. Thank you for watching.